Welcome to my YouTube channel. Thanks very much for the subscription. For those who have subscribed, those who have not yet subscribed, do one thing: subscribe, put on a notification, and we continue to learn. Today, we are going to be looking at one of the major pathways in the body, and this one is responsible for controlling organ size through regulation of cell proliferation, apoptosis, and stem cell repair. So, this pathway has regulatory proteins and activators and transcriptional proteins. We are going to be finding these proteins, and MAST1-2 is going to be standing for mammalian sterile trait-like protein 1 or 2, type 1, type 2. Then LATS is going to be standing for large tumor suppressor type 1 and type 2. Then SARV1 is going to be standing for Salvador. Then MOBI1 is going to be standing for what? MAPS1 binding protein. Then you're going to have in NF2, which is a neurofibromatous protein type 2. The YAP, which is a yes-activated protein. So the TAS is transcriptional co-activator with PDZ binding domain. Then the TED is transcription enhanced associate domain. So we're going to be finding these proteins in our pathway. Let us go direct to the pathway and see what happens in the pathway. Going to the actual pathway, what really takes place in the pathway. So when the pathway is off and when it is not turned on, what do I mean by this? When there is no ligand that is binding to our receptor, so this is our receptor. So when there is no ligand that is binding to our receptor, what is going to happen? The neurofibromatous protein is not going to be activated. So when the neurofibromatous protein is not activated, we are not going to be having phosphorylation. So when we don't have phosphorylation of the mammalian sterile trait-like protein type 1 and 2, that is MAST1 to 2, we are not going to have this dimerization occurring. So this dimerization between MAST and Salvador takes place when we have phosphorylation of this one from activation of the neurofibromatous protein. What else is going to happen? The LATs, the large tumor suppressor type 1 and type 2, are also not going to be phosphorylated. So we are not going to be having the dimerization between the LATs and the MAPS1 binding protein. So we are going to see LATs is not having ability to translocate into the nucleus. If it cannot translocate into the nucleus, what is going to happen in the nucleus? Our YAP and TAS are not phosphorylated. They are going to come and bind on our TED. When YAP and TAS bind on TED, when they are not phosphorylated, we are going to see transcription of genes which are responsible for cell proliferation. So when the pathway is switched on, what are we going to be having? We are going to be having a ligand, for example, CD44 binding to our ligand. So when they binding to our receptor. So when the ligand binds to our receptor, what is going to happen? We are going to be having the activation of the neurofibromatous protein. When this protein is activated, it's going to lead to phosphorylation of the mammalian sterile trait-like protein 1 and 2. So after this one being phosphorylated, we're going to see it dimerizing with Salvador. So formation of this dimer is going to lead to phosphorylation of large tumor suppressor and the MAPS1 binding protein. So as the large tumor suppressor type 1 and type 2 is phosphorylated, it's now it has ability to translocate into the nucleus. Once it translocates into the nucleus, it's going to phosphorylate the YAP and TAZ. These two, once they are phosphorylated, they are going to change the configuration, so they can no longer bind to the TED protein. So, using protein 14-3-3, this is a carrier protein. It's going to come and carry the TAZ outside of the nucleus. So this is the phosphorylated TAZ. Phosphorylated TAZ is going to be carried outside of the nucleus by this carrier protein. The YAP is also going to be carried out of the nucleus, the phosphorylated YAP. So in presence of CK1, it's going to be degraded. So we are seeing switching on of this pathway is going to lead to degradation of these two proteins. So, what is the implication in this? When we have a mutation in the neurofibromatous protein, it means that the process is not going to continue down. Once the process does not continue down, we are not having lights being translocated into the nucleus to phosphorylate these proteins. So as these proteins are not phosphorylated, they are going to continue to bind to transcriptional enhanced associate domain and lead to continued transcription of proliferation genes which trigger proliferation, leading to what? To cancer. When we have overexpression of this protein, the YAP protein, and deletion of what? Of the MAST1-2, we are going to have hepatocellular carcinomas. When we have a mutation in NF2, that is neurofibromatous 2, we are going to have schwannomas, meningiomas. Then other cancers related to this pathway, we have gliomas, we have colorectal cancers, we have ovarian cancers. Then we have what we call renal cell carcinomas, when we have deletion of LATs in the kidney cells.